Okay, so let's take a look at a problem. And this is our first problem of a Practicum 2. So we see that checkers is played on an n by n checkerboard with one side playing the black pieces and the other side playing the white pieces, just like every game of checkers ever played. Given a board size n, so this is a checkerboard that can be of various sizes, and the positions of the black and white checkers, create a program to print out the resulting checkerboard. Okay, so as input, we see we are receiving an integer n denoting the size of the board. So first we're going to get the size of the board, and if we look at our sample input, it's always good to cross compare. We see we're first receiving the number 4. So we're going to get one integer relating to the size of the board. Then next we're going to get an integer b denoting the number of black pieces to be placed on the board, followed by b pairs of integers rc denoting the row and column of b black pieces. So if I look at our sample input, that means I expect that I'm going to see 3 black pieces, and so it's going to be followed by 3 pairs. So if I look, this is what our input looks like, if I was making notes to myself, I'd say, okay, that's my number n. This is going to be the number b of black pieces, followed by the first position, the row, and column of each of the pieces. So I see 0, 2, 1, 1, and then 1, 3. So that's what that looks like as input. And if I look back to my list of input, at the top, I'm going to get an integer w denoting the number of white pieces to be placed on the board, again, followed by that many pairs of representing the row and column of white pieces. So that's what that tells us there. So that means we're told how many white pieces we're going to have and their positions. So there are only 2 of them that are coming this time, and they're going to be at position 2, 0 and 3, 3 row, column. Okay. So it tells us the bottom left corner of the board is 0, 0, and the top right corner of the board is n-1, n-1. So if I have in this case, a 4x4 board, then that means that it's going to look like 0, 0 down here. This would be, this is row 1, column 0, row 2, column 0, and row n-1 or 3, column 0, and then it's going to, of course, go over the columns increase as we go in this direction, so that the top right corner, as stated above, is row n-1, n-1. And in this case, n was equal to 4 for our sample input. So this just keeps going. But I will put 0, 1, 0, 0, 2, 0, 3. Okay, and so hopefully you can see where that's going. And this would be 1, 3, etc. I should have just filled it in at this point. Okay, so it's always best when you start off to kind of plan out, like, what is it this piece is doing? Well, we receive this sample input. We see we've got our n. That sets up the size of the board that we're going to be working with. And then we get these little pieces here. We get the positions of each of the black and white pieces in order. So I see that I'm going to put a black piece in 0, 2, so that's right here. And so in the output that we see, which is on this left-hand side, we see we put an asterisk there. And if we look at what the output is asking of us, it says we're going to output an n by n board, where an empty square is denoted with a full stop, a period black piece is denoted with an asterisk and a white piece is denoted with an O. Okay, so that's our goal. That's what we need to do. So the first thing we're going to have to do is read in this information. So I've already set up a main method, but after that, I've left the work to us. So the first thing I need to do is read in that information, and to do that, I know I need a scanner class. So I'm going to import, I'm just going to import java.util.star, which is all of the Java utilities libraries, which includes the scanner class, and that way I know I can create a new scanner, specifically reading from system input. Okay, so now I want to read in my details. So what do I need to hold? The first piece, first I need, and you can think of it however you want, final int n equals in dot next int. We're only reading in integers, which makes our input pretty easy. We'll just keep using next int, but that's the size of the n by n board. Okay, so now I have the size of the board. What I need after this is to create the board itself. But the board is going to hold characters. It's not going to hold integers. I'm given integer positions, the row and column of each of the pieces that I'm putting, but what I'm actually putting in there are characters. And so we're going to create a character array to hold those, and it's a two-dimensional array. We'll call it board, and it's going to hold, it's going to be an n by n board. So it's a board of size n by n, based on the value that we read in just prior. And so initially, these are populated, it's n by n, but it's populated as null. And I want to kind of set the stage that it's going to, if it's empty, it's holding those just periods. So I can say for int r equals 0 to r less than, so I'm going to let the rows go from 0 to less than n, and r plus plus. So there's a few ways to do this, of course, but this is the probably most straightforward way that most people would think of, is let the rows run from 0 to n, let the columns run from 0 to n, C++. And so I have now inner loops. So this is letting my rows run from 0 to n. The inner loop is letting my columns run from 0 to n. So for each position, I'm going to set board in row R, column C. I'm going to just set that, assign that the value, period, done. And so now if I were to output that, and we can practice outputting that, so you can decide to do these things in different orders. So here's our input. We're starting off up here, but what we can do is think about, like, let's just test it out and make sure that I've got a board, especially because I'm going to steal this. It's always okay to take your own work. Again, I'm going to want to loop through each of the rows, and I'm going to go through each of the columns, but I'm going to show you something. So this time around, what I'm going to do is, first, I'm going to remember that first I want to print across a row. I'm going to output, I am going to do that, but I'm going to actually output what it holds. So what I'm doing, so you can see what this does, is I'm going to output the actual row index and column index. And so this is printing, and I'm going to do a print line right at the end. So what that means is, as I go across the column, I'm going to output the pairs. So on this line here, line 59, I'm outputting the pair that where I'm at in this loop. Okay, and the reason I'm doing this for a very specific reason. Okay, I'm going to go ahead and click run. We'll see what happens. I'm going to have to give it the input. So it's first expecting the board size. So I'll give it 4 by 4, and we'll see what that looks like. And the reason I wanted to point this out is this is what we get. So I'm actually, I'm not printing out what's held in the board, but I'm showing you that when we do output initially, it's running from sort of that common 0, 0 in the top left to 3, 3 down in the bottom right. And that wasn't what was asked of us. So just to get that right first, we have to flip everything. And so if I think about what that means, it means I'm letting my row go from 3 down to 0, and I'm letting my column still continue to run from 0 to 3. So what that means is in our output, we want to change this from running from n and continue as long as it's greater than or equal to 0. And instead of having the row go up, we want it to go down. And so if I run this again, hopefully we'll see, I'll put in a 4, and what we get, oops, what did I do wrong? Oh, this isn't working as I wanted. I want to go from n minus 1. So this is why checking things first is pretty useful. So going from 3 down to 0, so I've got 0, 0 in the bottom left, 3, 3 in the top right. Okay, so now that's ready to run, except I did that just as a test to show what that looks like, but what I actually want to print is not that, right? What I want to print right here is what's held at the board in that exact location in row index R, column index C. So now if I do that, and you'll see pretty quickly why I did it the way I did. If I had done that in this location, it's really hard to tell if it's right or wrong. I could even flip the columns and rows and no one would know at this point. So, okay, so that's ready to go. So now, why would I do the output first? Good question. One, I could get that right and finesse it, but 2, it allows me now, I can take in that first line of input and make sure things are working the way that I expected if I want. Okay, so I can get the black pieces working. So I'm going to read in the black pieces and process at the same time. So what that means is I'm going to read in that next line, this bit here, and I'm going to allow those pieces to be placed in the board. Okay. And my output is done. So at this point, I just need to get in those next pieces. So if we remember that this is what that next line looks like, where this is kind of our pairs, right, of rows and columns. So it kind of looks, we're going to get a bunch of different integer pairs. So the first thing we need to do is figure out how many black pieces this is the number of black pieces. We'll read that in. So this is the number of black pieces. And then we're going to loop through read those pairs in, and as we do, so we need a loop to do that. We need to, for each of the black pieces, we need to read in a pair. So we're going to say, so I can say for I less than, from 0 to I less than B, increase I. So this is my loop that's I'm going to use to read in however many. I'm going to let it go from 0 to just less than B. So this is 0, 1. I don't need to store those. I just need to put the details in. So what I'll do then is stick in a black piece. And if we look back up at our instructions, black pieces are represented by an asterisk. Okay, so we're going to place the pieces and we're going to place an asterisk in the right place. So we're going to read in for each black piece, we're going to read in a row. Dot next int, we're going to read in a column in dot next int, and then we're going to take in our board at row column call, we are going to set that equal to star. Okay. So this bit here should read in and position the black pieces that are provided to the program. So let's see if we can do that. We'll run it from there and see if that works. First, we'll put in a 4. And now notice last time I entered 4 and it output because that all of the input was done being read in. This time it's expecting that next line of inputs. So 0, 2, 1, 1, 1, 3, something like that. And we can check that did what it said. So this 0, 2 should go to 0, row 0 is down at the bottom. So this is our 0, 2. And then we see a 1, 1 and a 1, 3. Here's our 1, 1 black piece, and here's our 1, 3 black piece. So everything's working as expected. Next thing we're going to do is read in the white pieces, and I'm going to copy and paste because I'm a lazy programmer. I don't need to recreate something that I just wrote. So I'm going to read in the number of white pieces. We'll call it W. And this time the input's coming in the same. The only difference I need here is these are the white pieces. So first we get the number of white pieces. We're going to go through that, but in this case we're going from I equals 0 to I less than W, and we're going to put an O there. Okay, so that's awesome. Let's see if it works. This time we'll take in the 4. We have 3 black pieces, 0, 2, 1, 1, 1, 3, say, and let's give it 3 white pieces. And this time I'll put in 2, 2, 1, 2. So we're going to put 1 between those 2 black pieces, and then maybe we'll put 1 in the top right corner, 3, 3. I'm picking where they're going at the moment, so you can see what that looks like. I put a white piece in 2, 2, which should be kitty corner down from that top right corner. I put 1 in 1, 2, which I knew was right between those 2 black pieces, and I put 1 in the top right corner. So that all seems to be working. That's my solution for problem 1, and it seems good to go. If I had taken this exact input, which I can do, I'll run it and I'll put the exact input in. We should see that we get the right answers: 3, 0, 2, 1, 1, 1, 3, and then 2, 2, 0, 3, 3. We'll see that our output matches as we'd hope. So that's it for problem 1. On to problem 2.